Okay, so in the last video, we left off with finding a formula for a linear function. And so remember that our formula for a linear function is y equals mx plus b, where m is our slope and b is our initial value or our y-intercept. Okay, so it says find a formula for the linear function described below. So we want to find g of x, so this is acting like our y. And it says g of 3 equals 2, and g of 6 equals -1. So we only need one thing to find our formula, and that's, well, actually we need two things. We need 2 points. So how can we rewrite these as ordered pairs? Well, these guys are just inputs and outputs in function notation. So this guy right here says when the input is 3, the output is 2. So as an ordered pair, we put the input first, our x first, and then our output, or our y value, comes second. Okay, so that's our ordered pair there. Same idea here. Here our input is 6, and our output is -1. So now that we have 2 points, we can use the slope formula. After we find the slope, we can plug everything in and solve for b, just like we did in the previous video. So let's call this point x1, y1. This is point 1. And let's call the second one x2, y2. You could have easily reversed the points. It doesn't matter. And so our slope formula tells us that the slope is equal to y2, which is -1, minus y1, which is 2, all divided by x2, which is 6, minus x1, which is 3. Let's go ahead and simplify. So the top simplifies to -3, and the bottom simplifies to 3. -3 divided by 3 is -1. So this is our slope, okay? Now what we do is we plug in y, m, and x and solve for b. Now you can use either point to call x comma y. You can't interchange the two. So like, for instance, you can't say, well, hey, let's let x equal 3 and y equal -1. No, they have to come from the same ordered pair. Which ordered pair you use doesn't really matter at all. But I'm going to use this guy. Okay, so I'm going to say my input x is 3 and my output y is 2. We just found the slope, which was -1. And so using all of this, I'm going to just input all of these numbers in for y, m, and x and solve for b. All right, so we have y is equal to m times x plus b. All right, so this is just an equation here. Looking at the right side, we can simplify -1 times 3 is -3. And what I want to do is to get b by itself, I want to undo subtraction of 3 by adding 3 to both sides. And I get that b is equal to 5. All right, so my equation, and they tell us that g of x is our y value. So we have g of x, y, aka y, equals m, which is -1. I don't have to write the 1. I can just write -x plus b, which is 5. So this is our answer right here. This is our formula given these 2 points right here. All right. Okay, let's do an example like this. So the graph shows data from a linear function. Find the formula, and this time our input variable is n. So we can see n is on the x-axis, and our output variable is u on the y-axis. And let's go ahead and just, all we need are 2 points, right? We only need 2 points, that's it. If we can find 2 points, we got the equation, all right? So our equation, again, is y equals mx plus b. We need to figure out what m is, we need to figure out what b is, and I can do that because I'm given some ordered pairs here. I have 3 ordered pairs. I have this one, and this one. Which 2 you pick really doesn't matter at all. I'm going to just pick the first 2, so I'm going to pick this one right here. Now this one has an x value of 15, and it has a height or a y value of 2.5. So my ordered pair is 15, 2.5. That's x1, y1. All right. And I'll use this one right here as my second point. So this guy has an x value of 30 and a y value of 5, right? So this is going to be our second point. We'll call it x2, y2. And now all we have to do is use our slope formula. So slope formula says y2 minus y1, all divided by x2 minus x1. All right. So simplifying the top, we get 2.5. Simplifying the bottom, we get 15. And 2.5 divided by 15 is going to give us 1/6 when we reduce it. Okay, so this is m. So that's a slope. And the last thing to do is to figure out what b is. And again, we're going to employ the same technique. We're going to choose an ordered pair to plug in for x and y. We're going to plug in the x, y, and then we're going to plug in m that we just found, which is 1/6, and solve for b. Now, which point you use doesn't matter. I'm going to use the one without the decimals just because, I don't know, I don't like decimals. Rather not use them. So here, my y value is 5. So y is 5, and when y is 5, x is 30. So I'll plug in 30 for x. And let's go ahead and do that. We have 5 equals 1/6 times 30 plus b. We're solving for b. I'm going to actually write this over here. M equals 1/6, and I'm going to erase this so we have more room. Now 30 over 1 times 1/6 is 5, right? 30 divided by 6 is 5. So on the left we have 5, on the right we have 5 plus b, right? 1/6 times 30 is 5. Then I can subtract 5 from both sides to get b alone, and I end up getting b equals 0. All right, so b is equal to 0, m is equal to 1/6, so my answer here is going to be 1/6. My variable on the x-axis is n, so instead of 1/6x, I'm going to write 1/6n plus 0, which I don't have to write the plus 0. I can simply write this as my answer right here. Okay, so a line passes through the points -3, -2, and -1, -4. Which of these points are also on that line? All we have to do is get the equation of the line and then plug in the x and y values to see if we get true equations. All right, so that's the strategy we're going to use here. Because remember, what's coming out is a function, and the function says, hey, we can put in any x value we want, and we'll get a corresponding y value out. And let's see which one of these are going to give us valid answers. Okay, so the first thing I do when I have 2 points is I use the slope formula. y2 minus y1 all over x2 minus x1. It doesn't matter which one you pick as x1, y1, but I'm going to just pick this first one up here as x1, y1. x1 is -3, y1 is -2. And I'll do this one as x2, y2. So using my slope formula, I have y2 minus y1 all divided by x2 minus x1. Now these double negatives here make positive, so let me just rewrite this. This is -4 plus 2 over -1 plus 3. Okay, so -4 plus 2 is -2. -1 plus 3 is 2, so this gives me a result of -1 as my slope. Okay, good. So my slope is -1. Now the next thing to do is we're going to use our formula y equals mx plus b. We're going to choose one of these ordered pairs that we are given to plug in for x and y, plug in m, and get out b. So I'm just going to randomly choose this point to use for my x comma y. So in this case, x is -1, y is -4. And again, just to say this again, if you wanted to, you could have picked x equals -3, y equals -2. You could have done that and you would get the same answer, but I'm going to use these two, x and y. So we just found m is -1. So using these values, I'm going to plug all of these in here and solve for b. So we have y is equal to m times x plus b. So I get -4, -1 times -1 is +1. If I subtract 1 from both sides, I get that b is equal to -5. So that's my y-intercept. So my equation, my function, is y equals -1x, or just -x, minus 5. All right, so if my slope is -1, my y-intercept is -5. So this is my equation right here. And so what we want to do is we want to punch in the x values and see what we get out for the y values, right? We want to see which of these actually are ordered pairs that are on this line. So what I'm going to do is I'm going to erase some of this, make some room here, and write it back up here. We have y equals -x minus 5. That is our function here. So let's look at the first choice that we have. We have x is -9 and y is 12. Is that true? Is that going to be true? When we plug in -9 for x in here, are we going to get an output of 12? Well, let's see. So I have y equals, I'm going to plug in -9 in for x, keeping that negative there. I'm just plugging it in strictly for x. And so these double negatives become a +9 minus 5. And this is going to give me y equals 4, which unfortunately is not 12. So that guy is not on the line. This is not a valid ordered pair. All right. So let's do the next one. When x is -25, is it true that y is 20? Is that going to satisfy this? Well, let's see. If I plug in -25 in for x, I get -25 minus 5. And again, those double negatives make a +25. And yeah, we do actually get 20 here. So yeah, that is on the line. All right. Let's do the next one. When x is equal to 0, does y equal -6? Nope, because if we plug in 0 here, we get 0 minus 5 is -5, not -6. Next one. The next one is, when x is 2, does y equal 7? Well, if I plug in 2 for x, I get -2 minus 5. And if I simplify, I do get -7. So this is indeed on the line. And finally, we have x is -10, y is 14. So when x is -10, is it true that y is 14? So plugging in -10 for x, those double negatives make a positive. So we get 10 minus 5, which is 5 and not 14. So this is not an answer here. Our correct answer is going to be choice 2 and choice 4. Okay, so far we really just looked at linear functions algebraically. We talked about the formula, the slope-intercept form, y equals mx plus b. And we talked about the slope equation, y2 minus y1 all over x2 minus x1. We also, in the very beginning of this section, we looked at tables of values. So like we looked at several ordered pairs. And we saw what was happening when x was increasing by 1, y was increasing by a certain amount, and that told us what our slope was. What I want to do now is I want to introduce linear functions in a graphical sense. So all of these, let's go back to the very beginning. I just want to bring this back to what we've been doing. Remember these scenarios that we had? Well, in these scenarios, we had ordered pairs. So like this table gave us the ordered pair 1 slice, 3, we got 2 slice, 6, 3 slice 9, 4 slice 12, and so forth, right? Infinitely many points. And if you were to graph these ordered pairs, this is just our x and our y values, right? If we were to graph these guys, we would get a straight line. That's why we call these things linear functions, because when we graph the points, they make a line. So 1, 3, and of course I'm gonna run out of space, but we really just need 2 points to graph a line. So our line is gonna look something like this. And we talked about, how to write the algebraic formula for this. The algebraic formula, remember, was just y equals 3x. All right, so this function makes a picture that looks like a line, and that was for all of these situations. All right, so let's go back to this slide. Go back to this slide. Oh, here we go. Okay, so the first thing, we're going to talk about the slope, and we're going to talk about the y-intercept, where we can find them on the graph. So the y-intercept, remember, was b, and y equals mx plus b. And basically the y-intercept is just where the line crosses the y-axis, or the vertical axis. So in this picture, it crosses right there, so that's our b. Now, for a y-intercept, the x value is always 0. So this thing right here is going to have an x-coordinate of 0 and a y-coordinate of b. That's true for all of our y-intercepts, because we don't have any horizontal component to deal with. It's just 0, right? We only cross the y-axis with our y-intercept. So let's do some examples here. It says, which linear function is a match? All right. So we can figure this out solely based on the y-intercepts, because they all have different y-intercepts. So what's the y-intercept for a? Well, the slope is 1, because that's the number in front of x. That's true. And the y-intercept is 0, right? Because we don't have a plus b at the end. It's just 0. So which one of these crosses the y-axis at 0? Well, it has to be the red line, right? All right, it crosses right here at y equals 0. All right. What about the next one? Y equals negative 4x plus 5. Well, again, we can figure this out solely based on the y-intercept, which is b, which in this case is 5. So which of the two lines that are left cross the y-axis at y equals 5? Well, it's got to be this guy, right? This guy has an ordered pair 0, 5. And by the way, this one down here has an ordered pair 0, 0. So our answer here is the green line. And finally, this last guy, this 2x minus 4, has to cross at y equals negative 4, right here. Maybe I'll do this in blue. So this ordered pair, well, of course, it's crossing the y-axis, so it has to have an x component of 0, and the y component here is negative 4. So this is going to be my blue line. All right, so we just talked about y-intercept. That's pretty straightforward. Now I want to talk about slope. So what slope actually is, graphically, it measures how steep the line is. So like, I always think of slope in terms of like mountains, right? For those of you that are watching that like to hike, you know that hiking a really steep mountain is very taxing on the body, all right? So a very steep mountain has a very high slope. A flat mountain has, a relatively flat mountain has a lower slope, okay? Now, you can have some different scenarios for what your lines look like. The first scenario is if your line faces this direction, if it's going up. So that's a positive slope if your line looks like that. In other words, if you were to put a little guy on the line, would he be walking up the mountain or would he be walking down the mountain is what you want to ask yourself. If he's walking up the mountain, like he is right here, it's going to be a positive slope, right? because we are moving from left to right. That's what we're thinking of in terms of our direction. So he's walking up the mountain, positive slope. On the other hand, if you put a guy on there and he's walking down the mountain, that's a negative slope. All right. So, right. And then we could also have something that looks like this. Zero slope is a completely flat terrain. So if you put your person on there and he's walking, it's completely flat. So that's going to be a slope of 0. Okay. So again, the slope measures how steep it is. If you have, and we use numbers to measure things. So let's say your slope is 5. You're talking about a slope of 5 versus a slope of 100. Which one's steeper? Well, it's going to be the one that has a slope of 100, right? It's a bigger number. And so the larger the slope, forgetting about the negative sign if it's a negative slope, the steeper the line. So negative 100 is going to be steeper than negative 5. Okay? 100 is going to be bigger than 5, so it's steeper than 5. So let's do some examples where we match these lines based on their slopes. All right? So notice that all of these lines have the same y-intercept. And that's going to be 0, right? All of these guys cross here at y equals 0. So that's our B, so we don't have to worry about that. The only thing that's different in each of these cases is the slope. So, which one of these is going to have the biggest slope, the steepest line? That's got to be the biggest number, which in this case is 10. This is going to be the steepest. Right? 10 is the steepest. And which one's going to be the flattest? So we have 1, 2, 1/2, 1/10. Which one's going to be the flattest? Well, it's going to be the smallest number. So which one is the smallest number? 1, 2, 10, 1/2, or 1/10? Well, 1/10 is the smallest number. 1 divided by 10 is smaller than 1 divided by 2. So this is going to be the flattest, right? Okay, so let's go ahead and put these in order. So let's do it from flattest to steepest. So this one is going to be, so from flattest to steepest, this is our order. We have E as the flattest, followed by, what's the number that's the next smallest? Well, 1/2, right? Followed by 1/2 x, which is D. Followed by 1, which is A. Followed by 2. And then finally, the steepest is C. Okay, so that's flattest to steepest, our slopes there. Notice that all of these are positive slopes. So if you were to put a person on each one of these, they would be climbing up the mountain. Okay. Yeah, so like if we were to match these letters with the actual pictures, well, the flattest one, which was E, has to be this guy right here, right? This flat line is E. Okay, so that's 1/10 x. The next flattest is 1/2 x. So which one is the next flattest? Let's see. It's going to be this black one is 1/2 x. So this is going to be D. That's the next flattest. Followed by A, which is going to be this red one. That's the next steepest. And then B, and finally the steepest one is the purple, which is C. Okay, let's try this one. So this time we have negative slope. So if I put my guy on these mountains, he's walking down. These are negative slopes. Okay. So which one goes with which? Well, I know the flattest one has to be the smallest number, not counting the negative sign. So this guy's going to be the flattest. And this guy is going to be the steepest because 8 is the largest number. So which one belongs to which? Well, the flattest one is going to be B, which is the blue one, followed by the next flattest, the, less steep incline, which is going to be A. So that guy's in the middle, so that belongs with the red graph. Followed by our steepest one is going to be y equals negative 8x, and that's this green line right here. All right. Match each linear equation with its graph. Okay, so first of all, and use process of elimination, right, between positive and negative slopes. So I'm going to look at the positive slopes first. That's going to be the blue line because if I put a guy on there, he's walking upwards. And it's also going to be the black line. If I put a guy on there, he's walking up. So those two are positive slopes. So we can already eliminate this one and this one and this one from our positive slopes. So which of these belongs with 1/2 x minus 3? Well, we can look at the y-intercepts to figure that out. The y-intercept here is negative 3. So out of the black and the blue, which one crosses the y-axis at negative 3? Well, it's the black, right? So this guy is going to be D, black. And then that means the other one with the positive slope has to be the blue line, and it does indeed cross at y equals 1. So this is going to be B. And maybe I should have did this in a purple color. Let's do that. Okay. Oh wait, no, this was black. Sorry, guys. This was black. Okay. So far, D and B are gone. Let's look at the other ones. So the red one is a completely flat terrain. If you put this guy on here, he has no incline. So that's going to be the only one that has a slope of 0, which is the line y equals 0. That's technically y equals 0x plus 0. So 0 slope, that's going to be red. Okay, now let's look at our negative slopes. We have one negative slope that crosses the y-axis at 1. We have one negative slope that crosses the y-axis at negative 3. And these are, so this guy right here is negative walking down the mountain, and so is this purple guy. Now the green one crosses at 1. So so the green one has to be this guy. So this is going to be what happened here? Oh, I'm sorry, guys. I'm messing this up. Oh, let's forget it. Okay, so the blue one was the positive slope that crossed at 1. So this was E. The black one was the positive that crossed at negative 3. So that was D. The red one is the 0 slope, so that's A. Okay, and purple crosses at negative 3, and it has a negative slope, so it's got to be this one because it crosses at negative 3. That's our y-intercept, and so this is going to be C. And so the last one has to be B, crossing at positive 1. All right, there we go. In the figure below, match the graph of each line to its equation. All right, so we can use process of elimination here. We can simply use, whether the slope is positive or negative and the y-intercepts. We don't really have to look at slope quite yet. So the first thing I notice is that this choice B is the only one that has a y-intercept of 0. So looking at all of those lines, which one crosses at 0? That's going to be y1. So this is going to be this one right here, crossing the y-axis at y equals 0. All right. let's try the other ones. So let's see. Yeah, I know it's kind of hard to see here, but let me rewrite this to make it look a little bit more clear. So this is, if I rearrange this, this is f of x equals negative 2 over 3x plus 1. I know this is hard to see, but it's an equal sign, not a negative. However, there is a negative right here. So this one is actually negative 1/2 x minus 1. So that's A, and then C is what we wrote here. So that's that. And this guy has a b of negative 1, y-intercept. This guy has a b of positive 1, and this guy has a b of 19 over 7. That's the constant there. So again, process of elimination here. Let's see. So, which of these crosses the y-axis at positive 1? Well, that's going to be this line right here. That's the only line that crosses the y-axis at positive 1. And that's y4. All right. So that's going to be this guy crossing at positive 1. That's our B. Okay, and then the next one is crossing at negative 1, which I see right here with this dotted line. It's a negative slope. So that's going to be y3 for A. And we knew that because it crossed the y-axis at negative 1. That's our B value. And the last one has got to be y2. So this has to be y2. Okay? Okay, so let's talk about finding the slope of a line graphically. All right, so before we found the slope two kinds of ways. We used the formula y2 minus y1 all over x2 minus x1. And we also looked at tables, and we said, like, if x is going up by 1 and y is going up by another amount, then the slope is that amount. So those two ways are definitely valid. Sometimes we can find the slope graphically a lot easier. And the way that we do that is rise over run. And what I mean by rise over run is a change in y over a change in x. That's what that means. And actually, it means exactly the same thing that we've been doing. And hopefully, you guys, I'll be able to make that connection for y'all in just a bit. But the idea here is that on a line between any 2 points, it doesn't have to be 2 points that are next to each other, like the blue and the purple. If we take the blue and the yellow point, for example, and do rise over run, we're going to get the same exact slope as if we took the blue and the purple, okay? So any 2 points you want, we do rise over run, and this is what we do. I'm going to start with blue and purple, okay? So what I do is I'm going to start at a point. I'm going to start at blue, and I'm going to rise until I get to the next point. So I'm going to rise up 1, 2. So I rose up 2. That's my rise. That's the change in y. And then to get to the purple point, I need to run to the right 1. Okay? So I rose 2 in the y direction, and I ran 1 in the x direction to the right. So my slope, my rise over run, is going to be plus 2 over plus 1, which is simply positive divided by a positive is a positive 2. So again, what this means is the same thing that we looked at the very start of this lesson. When x increases by 1, y increases by 2. Do you guys see that with the dots here? Let's look at purple to red. When x increases by 1, y increases by 2. When x increases by 1, y increases by 2. When x increases by 1, y increases by 2. Okay, so this is 1, 1, 1, 2, 2, 2. When x increases by 1, y increases by 2. That's our slope, okay? So that's how we do it, rise over run. Any 2 points will work. Let me show you what happens if we pick points that aren't next to each other. This is really cool, actually. Let me show you guys. What if I chose, what if I chose What if I chose the red point and the green point, Christmas colors? I want to get from red to green. So if I start at red, how much do I have to go up to get to green? I go up 1. So I go 1, 2, 3, 4, 5, 6. Okay, so I just rose positive 6 because I went up. All right, I rose up positive 6, and then from there I went over 1, 2, 3. You see that? Rise 6, run 3 to get from red to green. So when I put this in rise over run format, I get plus 6 over plus 3. Guys, what does 6 over 3 reduce to? It reduces to 2. So we get the same exact answer, aka we get similar triangles here, right? We just get proportional triangles. So you can choose any 2 points. You're going to get the same exact slope on a line, all right? Rise over run. Let's do another example. This time we have a negative slope. Look, here are my guys going down the mountain. So again, slope is rise over run. I can pick any 2 points. They don't have to be next to each other. So I'm going to pick the yellow and the green. If I start at the yellow, I go down 1, 2, 3. Okay. So I went down 3. So I'm going to indicate that I went down with a negative sign. Then I go to the right 2 units. I go 1, 2 to get to the green. And since I went to the right, that's positive. Okay. So rise over run becomes, how much did I rise? Well, I actually rose, quote unquote, negative 3. And I ran positive 2. And altogether, this is going to give us a net result of negative 3 over 2. This is my slope. Okay, so my slope is negative 3 over 2. What does this mean again? This means, hey, when x increases by 1, y decreases by negative 3 over 2. You see the connection there? Okay, so let me show you something else that's cool, okay? What if we started, so this is what we did here. What if let's say we start at red, that's our starting point, and we end at purple, okay? How much do I have to go up? I have to go up 1, 2, 3. All right, so I went up plus 3, and then I go over 1, 2. So I went to the left, so I'm going to indicate that I went to the left with a negative. Right is positive, left is negative. Up is positive, down is negative. So again, I get the same kind of answer here. Rise over run is going to be, I rose positive 3 and I ran negative 2, and again, the net result is still negative 3 over 2. Whether or not the negatives in the numerator or denominator is still negative 3 over 2. Now let's go back to this example with the positive. Now I want to show you something here, okay? What if let's see, I'm going to pick a different starting point. What if I start at orange and end at blue? Okay, well, to get from orange to blue, I go to the left, 1. No, I'm sorry. I'm rising first. I'm going down 1, 2, 3, 4, 5, 6. Okay, since I went down, I'm going to indicate that with a negative. Okay, I'm going from orange to blue. Then I need to go to the left 1, 2, 3 units. Again, I'm going to the left, so that gives me a negative result here. Now again, rise over run. I rose negative 6. I ran negative 3. A negative divided by a negative is indeed a positive. So you see how, you get the same answer no matter where you start, okay? Just remember, left negative, right positive, down negative, up positive, okay? Okay, so now let's practice graphing linear functions using the slope and the y-intercept. As I mentioned before, all we need are 2 points to graph a line. 2 points define a line, okay? The first easiest point to plot is the y-intercept. That's where it crosses the y-axis. That's our B. And after we plot the y-intercept, we can simply do rise over run to get another point, okay? So let's practice doing this. Graph the function f of x equals 3x plus 2. Now, I do want to mention to you guys that this is a shortcut that I'm teaching you. We can do this old school. This is how we would do this old school, okay? Old school, we would choose random x values. How about 0, 1, 2? And then we would get out y values by just plugging in the x values into the function. So the y value for x equals 0, if we plug in 0 for x, we get 3 times 0 plus 2 equals 2. So one ordered pair is 0, 2. Okay, this is old school way, all right? If I plug in x equals 1, I get 3 times 1 plus 2. This is going to give us 5. So now we have an ordered pair 1, 5. So when x is 1, y is 5. So 1, 1, 2, 3, 4, 5. And actually, we don't even need the third point, but we could plot it if we wanted to. When x is 2, y is going to be, well, 3 times 2 plus 2 is 8. Took me way too long to do this. Sorry guys, I'm a little bit slow today. Okay, 2, and then 5, 6, 7, 8. All right, sweet. We connect the dots, and we got a line here. Beautiful, beautiful. Now there's an infinite amount of points on a line, you guys. We can plug in any x value we want, get an output out. Any x value. Plug in negative pi for all I care. You're going to get out a y value, and you're going to be able to plot it on this graph, okay? But I'm only plotting 3 points. So that's old school way. And we can see from these ordered pairs what the slope is. Hey, we're adding 3. We're adding 3 when we're increasing by 1. Isn't that the slope, which is m? Isn't it true that b, the y-intercept, is 2? Well, hey, look at this first ordered pair. When x is 0, y is 2. That's our y-intercept. Awesome. All right, cool. So that's old school way. You can always revert back to this if you don't like the shortcut, but I'm going to show you the shortcut by plotting the y-intercept first and then doing rise over run. So let's get rid of this and do it the other way. Okay, so the first thing we're going to do is plot the y-intercept, which is b. So that's 2. So that's where it crosses the y-axis. Boom, bam, that's it. Our first point is done. We're halfway done, you guys. All right, so now what I'm going to do is I'm going to use this slope to do rise over run. So rise over run is my slope, which is m. And guess what, y'all? It's 3. It says rise 3, and it's any number by itself is understood to be over 1. So we're rising 3, and it's positive, and we're running 1, also positive, right? So I'm rising 1, 2, 3, and I'm running to the right 1, both positive, and this is my second point. Bam, bam, bam. That's it, y'all. That's the line. Now let's verify that we did this correctly. What point is this if you look at the graph? Well, this is x is 0, y is 2. This point right here is x is 1, y is 5. Is this really on the line? Is this on the line? Well, yeah, right? Because f of x is y. And so we have, for this ordered pair right here, we have 5 equals 3 times 1 plus 2. Hey, that's true. Right? And same thing here. We have f of x, which is 2, equals 3 times 0 plus 2. Hey, that's true. So the shortcut works. Awesome. Okay, so that's how you do it. Let's keep doing the shortcut. It's much easier, I think, than making the table. But just know that you can make a table if you want. All right, let's do this one. The first thing I'm going to do is I'm going to write the slope first. I don't like the slope in the back. It makes me nervous. I don't know why, but it does. So I'm going to write it like that. Same exact thing. Negative 2x plus 5. Same exact thing. So the first thing I'm going to do is I'm going to plot my y-intercept, and that is at 5. That's my b. So 1, 2, 3, 4, 5. That's where it crosses the y-axis. Awesome. Now, rise over run. My m is going to be what? Well, I can do this one of two ways. I can either rise -2 and run +1, or I can rise +2, run -1. So either one of these is valid because the net result is negative. I hope you guys see that. Test it out to see. Let's do the first one. So I'm going to rise -2, so go down 2, 1, 2, and then I'm going to go the right 1. That's what I'm going to run, connect the dots, and there's my negative slope. Now, if I were to have done it this way, if I were to have first rose 2 and ran -1, I would have gone up 1, 2, and then I would have gone to left 1, and I would have gotten my point right there. Same thing, it's still on the line, still valid. All you need are 2 points to make a line. So that's how we plot the line y equals -2x plus 5. Let's do another example. First things first, we're going to graph B, which is 1. So here's my y-intercept right there. From B, we're going to do our rise over run. Now again, there's 2 ways you can do this, but I'm going to do it, and this is our slope. So I'm going to rise -2 and run +3 from the green point. So I'm going to rise -2, so I go down 2, that's what that means. And then I go to the right 3 since it's positive. 1, 2, 3. And I end up right here. And there's my line. Pretty cool, huh? All right. Let's do another example. I encourage you to pause the video, try this one on your own. Okay, this time we have a y-intercept of -3/2. This is the same thing as -1/2, 1.5, if you will. So this is going to be -1.5 is about right here. Do this in green. So that's our first point. And then our slope is 1/4. Let's see. So if I rise 1 and run 4 from the green point, since I'm at the halfway point, I have to rise 1 in this fashion right here. So I just rose 1. Do you see that? Since I'm at the halfway point, I have to go to the halfway point here. So I rose 1. That's rising 1. And then I want to run 4. So 1, 2, 3, 4. And there's my point right there. And then I can connect the dots. Again, you can make a table for this if you want, but that's the idea. All right, let's do this one. Now, this guy isn't in y equals mx plus b form, so we want to do that first so that we can easily identify b and m. So what I'm going to do is I'm going to start by, I want to get y by itself, so I'm going to first get rid of this positive 2x by subtracting 2x on both sides. And then I'm going to divide everybody by 3 to get y alone. So I need to divide this guy by 3 and also this guy by 3. So let me rewrite this down here. 18 divided by 3 is 6. -2 divided by 3 is simply -2 divided by 3. Can't really do much with that. So this is my equation in y equals mx plus b form. If I want to, I can write the slope first, if that makes it easier on you. So this is going to be -2/3 x, positive 6. This is my equation in y equals mx plus b. And it's asking us to graph it. So I'm actually going to write this over here so I have room to graph it. So let's go ahead and just erase this. So our y-intercept is 6. We can see that's our b. So 1, 2, 3, 4, 5, 6. That is our b right there. And then our slope is -2/3. So this is rise over run equals -2 over +3. So I'm going to rise -2, so I'm going to go down 2, and then I'm going to go to the right 3. 1, 2, 3, and then I'm going to plot my point. Cool. And that's all I have for you guys. I hope you learned something about linear functions. I think they're super interesting. Yeah, thanks for watching. I'll see you guys next time.